Here, chapter 7, coordinate geometry. Let's see what is it all about. So here, coordinate geometry. We know in geometry we learned about the shape like square, rectangle, trapezium, all those shapes, circles, okay? Here in coordinate geometry, we'll be learning, okay, how to solve those geometrical problem by using algebra, which means both here algebra and geometry will be learning here both, okay? Basically it is solving geometrical problem by using algebra. In algebra we know we use the variable here x, y, z, okay? So here we'll be using here x, y, z here also, okay, like we do in the algebra. So let's see here. First here, what is it all about, this coordinate geometry? Now in a plane, any flat surface, we call it plane. So this is x-axis and this one here y-axis. You have learned something this in class 9 also. We are just repeating, I will be repeating some part, okay? So a plane, any flat surface, we call it plane. So these two axes, x-axis and y-axis, mutually they are perpendicular to each other, okay? They cut each other perpendicularly. And this plane is divided into 4 regions. So that is here, this 1, here 2, here 3, here 4. These regions we call it quadrants. So here quadrant. So we call first quadrant, second quadrant, third quadrant, fourth quadrant. Goes like this. So here this side, this is here positive, like 1, 2, here 3. It goes this side also positive, 1, here 2, here 3. This side will be minus 1, minus 2. That is what we do like in drawing graph here, okay? So in this first quadrant, both the abscissa and ordinate are positive. Now first let's see what is meant by abscissa and ordinate. Now for example, say here is a point here, I'm just taking a point, okay? So here this point, let's say the coordinate of this point from here to here, the distance of this point from here to here is here 2. And the distance of this point from x-axis is here 1. The distance of this point from y-axis is 2. The distance of this point from x-axis is 1. So here we have a pair of number. This pair of number we call coordinates. That means every point on this graph, okay, every point on this plane, it can be represented by a pair of number. For example, here, let's say here, the distance of this point, okay, from here to here, that is here 3. From here to here 3. So this is minus 3. The distance of this point from this x-axis, that is from here to here, this from here to here is same with from here to here, so that is here 2. So the coordinate of this point is minus 3, 2. So this pair of number we call coordinates. So between these coordinates, now here, the first one, okay, just taking the example, say point A. So for this point A, the first one here, this 2. The first number here 2. We call this one coordinate of x-axis or abscissa. We call here abscissa. Then this one, second one, we call it this one here ordinate. Ordinate. So the first, this abscissa is also called here, it is actually, yeah, it is here coordinate of x-axis, okay? These two we call here coordinate of x-axis. And here second one, this one here, this ordinate we call here, this is coordinate of y-axis, okay? So you need this, don't forget. So here any point on a graph can be represented by a pair of number called here coordinates, or we say order pair. Okay, the first number we call abscissa, second one ordinate. Abscissa or coordinate of x-axis. So when you say abscissa or coordinate of x-axis, it is the distance of this point from y-axis. Okay, for example here 2, 1. 2 is the distance of this point from y-axis, from here to here. So the distance of this point from y-axis we call x-coordinate or abscissa. Okay, the second one we call it, this one here, ordinate or coordinate of y-axis. It is the distance of this point from x-axis, that is from here to here is 1. Okay, from here to here is 1. So in this class 10, what we are going to learn in this coordinate geometry, here we'll be learning here basically here 3 things. That is here distance formula, okay, then here section formula and area of triangle. So here distance formula, if we know the coordinates of 2 points, let's say here A, here say this one here B. If we know the coordinates of these 2 points, we can find the distance between this. We can find the distance between this AB, okay, by using distance formula. Okay, so for any 2 given points, okay, if we know their coordinates, we can find the distance between them. So we can find the distance between AB by using distance formula. So here we'll be coming here distance formula. Okay, so let's see here distance formula first. Actually this distance formula, it comes from Pythagoras theorem, but here without full explanation how the formula comes. Okay, here you can do something where you can remember the formula easily. Okay, so here distance formula. So let's see here distance formula. So we say here, suppose a point here E, let's say the coordinate of this point E, let's say here x1 y1, here B x2 y2. Now we are going to find the distance between this EB. Okay, and this x1 y1 x2 y2, these are the coordinates of these points A and B. Okay, now here we say here distance equal to here square root of, we can say here difference of, right, in short here this is difference of abscissa abscissas whole square plus difference of ordinates whole square. It comes from the Pythagoras theorem. That's why here this whole square is coming like this. So here this distance equal to square root of difference of abscissa plus difference of ordinate. Now here distance here EB, so let me write here this EB, so equal to here difference of abscissa. What is the abscissa here? Abscissa is the first one. Okay, we know here abscissa is this first one. So here abscissa for this point B is here x2. So here difference of abscissa, difference means we have to subtract. Then which one to subtract from which one? You can subtract any one from other because of this square. So which means here we can write here x2 minus x1, okay, whole square, okay, or x1 minus x2. You can write any one because of this square. For example, say here 5 minus 2. 5 minus 2 whole square, you will get 9. 2 minus 5 whole square also, minus 3 whole square, you will get here 9. So why this 5 minus 2 whole square 9 and 2 minus 5 whole square 9? Why these two are equal? Because of this square. Okay, so like that here we can write any one here first with the x1 minus x2 or x2 minus x1, anything, then plus difference of ordinate. So here what is the ordinate here? The ordinate here is here y1. What is the ordinate here? Ordinate is here y2. So the difference, so we have to subtract here also. Let me write here y2 minus here y1 here whole square. Then we put here square root. So this is the distance formula. When we say here distance formula, this one we call here distance formula. By using this, we'll be finding here distance. But here remember, when we use this distance formula, we'll not be writing the same this formula, or even we will not be writing this. But we'll be using the concept, the idea of this. How this formula comes, you should not forget. We'll not be writing the same formula. Without writing formula, we'll be using. Okay? We'll be using, but exactly we'll not be writing. We'll be writing like this by using the equation, not this with the formula. Okay? Now let's see here. Now I'll show you what I mean is here. For example, let's say P is a point here 2 minus here 5. Okay? Let's say here, and here Q. Okay? Q minus 3, let's say minus 7. Okay? Now we want to find the distance between this PQ. To find the distance between this PQ, we can say here PQ equal to, now here square root, difference of, we'll not be writing this, but difference of abscissa. You need to remember this, difference of abscissa. What is the abscissa here? So the abscissa here is here, this one here 2, and here is minus 3. Difference means, as I said, we can write any one first here. So when you write here like this, here difference of abscissa or ordinate, you always write the bigger one first. Bigger one means between this abscissa 2 and minus 3. 2 and minus 3, which one is bigger? Now here 2 is bigger, so I can write here 2 first. Then again here we have to write minus 3. Actually this is here 2 minus 3 like this. We have to subtract like this. So this 2 minus 3, that minus we can write here directly here plus. Minus multiplied with minus is plus. So we can write 2 plus 3. So 2 plus 3 whole square. Then here plus, in the formula here plus. Then difference of ordinate. Ordinate is here minus 5. Here this one here, ordinate is minus 5. And here ordinate is here minus 7. So difference, we can write any one first. So bigger one first. So minus 5 and minus 7. Which one is bigger here? Minus 5 and minus 7. So it is minus 5 is bigger. So we write the bigger one first, minus 5. Then minus 5, minus 7, like here, minus 7. So minus means it will come here plus. So 7 here whole square. Now we get here this one, 2 plus 3 here, 5 square. This one here 2 square. So we get 25 plus here 4 square root of, we get here 29. Units, let's say units. So this is the distance between here PQ. Now I said here write the bigger one first. But what if I write here smaller one first? Like here 2 and minus 3. Minus 3 is bigger. What if I write minus 3 first? Minus 3, then here will come minus 2. Minus 3 minus 2 whole square. This will be minus 5 whole square. That is here 25. So same thing. But here if you write the bigger one first, see there is no minus here. When you write the smaller one first, here it has some minus here. So instead of doing here with the minus, we can do without this minus if we write the bigger one first. Okay? So this is how to use distance formula. So let's see from the exercise. So here is exercise here 7.1. E1 MCQ. P is a point on x-axis. According to question, P is a point on x-axis at a distance of 5 units from y-axis to its right. The coordinates of point P are. So where is this P? P is on x-axis at a distance of 5 on y-axis. Okay, to its right. So here P is a point on x-axis. So here is y-axis and this one here x-axis. So this P is a point on this x-axis. On this x-axis at a distance of 5 units from y-axis. From this y-axis at a distance of 5 units, okay, to its right. Right. So this is y-axis. 2 is right means this side. This is right side, here left side. So this side at the distance of 5. So let's say here from here to here is here 5. That means the coordinate of this point will be here 5, 0. Any point, for any point on x-axis, ordinate is always 0. So here 5, 0. So answer is 5, 0. So here number 1, here 5, 0. This is the answer. Then here number 2. A circle has its center at the origin and a point P 5, 0 lies on it. The point 6, 8 lies outside the circle. This statement is. Now we have to check whether this point Q lies outside the circle or inside the circle or on the circle. So a circle has its center at the origin and a point 5, 0 lies on it. So here what the question say is here is a x and y axis, okay? So this is the origin. This origin is 0, 0, okay? So here is a circle like this. So this origin is the center. And the point 5, 0, let's say 5, 0 is here. So this 5, 0, it lies here on this circle. So the question is asking whether this 6, 8, the Q 6, 8 is outside or inside the circle. So from here to here 5. 6, 8 means we will become beyond this point, here somewhere here, let's say. So 6, 8 means somewhere here. So that means the point this 6, 8 lies outside the circle. If it is 5, 0 or let's say 4, 1, 4, 2, so those things may be inside the circle. But 6, 8 means, see the abscissa, this is here 5. So 6 means you will be beyond this point here. So that means it is outside the circle. So this statement, the point Q outside the circle, this statement is true. Next here, the distance between the point A and B is. We have to find the distance between this A and B. To find the distance between this A and B, we have to use distance formula. So here, let's see here, in this number 3. So the point E and B, so let's just write here, E, B, equal to. Now, according to the question here, E is given as 2 minus 3, and here B is given as 2, 2. Now EB, we know EB equal to square root, then here, difference of abscissa. What is abscissa here? Abscissa is here 2, here is abscissa 2, same. So we can write any one first, because it is same, 2 minus 2, so here whole square. Then plus difference of ordinate. Ordinate is minus 3, here 2. As I said before, we have to write the bigger one first. That has some advantages. Instead of right here minus 3, writing 2 first will be better. So let's write the bigger one first. Minus 3 and 2. 2 is bigger. So if I write here 2 here, then 2 minus minus 3. Minus minus 3, we can write directly here plus 3. So whole square. So 2 minus minus 3. Minus minus, it becomes plus. So that's why 2 plus 3. So here we get here 2 plus 3 here 5. So 25. 2 minus 2 is 0. 2 plus 3 5. 5 square is 25. So we get here 5 units. So this is distance. So we have to write here units. Then here next here number 4. A point on y-axis at a distance of 4 units from x-axis lies below x-axis. A is a point on y-axis at a distance of 4 units from x-axis lying below x-axis. This is somewhat here similar to this. That point is on the right. Now here that point is below. Okay, not left right, but here below x-axis. So A is the point on y-axis. So here is x-axis and here is y-axis. So this point is on this y-axis. On this y-axis, a distance of 4 from x-axis. So a distance of 4 from here, at a distance of 4 means it can be upside here, let's say 4, or up, downside here 4. But according to the question here, it say this is from x-axis lying below x-axis. A is a point on y-axis. It is on y-axis at a distance of 4 units from x-axis, lying below x-axis. Lying below x-axis. So that point A is lying below this x-axis. That means this point A is here, below this x-axis. So that means the coordinate of this E will be here 0, 4, minus 4. If it is above this x-axis, it will be plus 4. For every point on y-axis, abscissa is always 0. So this is always 0 on this y-axis. So 0 minus 4. So answer is 0 minus 4. If the distance q xy from R and S is same, then which of the following is true? Distance of q from R and S is same. From R and S is same. So distance of this q from R and S is same. So according to the question, here is R, let's say here 5, 1, and here S. So S here minus 1, 5. So q is here, let's say R, here S. Let's say here q. Q is here. So q here xy. The distance of this q from R and S is same. So that means this RQ is equal to this SQ. Distance of this q from this R and S is same, means RQ and SQ are same. So according to the question, here it say RQ equal to here SQ. Now from RQ equal to SQ here, RQ equal to SQ, then we have to use distance from law. To use distance from law, have a look here. Here we write EB equal to square root like this. So when you write the distance from law, when you use the distance from law, here this square root will be there. Here this square here, one square root will be there. But if I square on both sides, here like this, then we can write without this root. For example, say here this root, if I bring this side, then this root will become minus here. So if I bring this root here, this side, this root will become here square. So like that here, if there is square here, this root will not be there. So to remove that root, I'm squaring here both sides. We can square later also, but I'm squaring here so that we can write without root here. So RQ, you see RQ, R is here, Q is here. Difference of abscissa. So abscissas are here 5 and x. You can write anyone first, right here x minus 5 here whole square, then plus again here difference of ordinate. So let me write here y minus 1 here whole square equal to, then again here for SQ, this SQ here difference of abscissa. So minus and here plus, plus is bigger, so I write here plus x first, then minus 1 will be plus 1 here whole square, plus then y minus 5 here whole square. Now from here we have to solve this one. We have to simplify, not solving, we have to simplify to get a simplest form of equation. Okay, so let's see here. If I express this in the form of a minus b whole square, this will come a square, then here minus 2ab. So that 2ab will become here then x, then here plus b square, this will come 25, then plus again a square minus 2ab, okay, plus b square, so 1 square is 1, then for this again a square plus 2ab, okay, so it come 2x, so plus 1 square is 1, then again plus a square minus 2ab, this will come here 10y, then plus here 25, okay, y square is here 25. Now here, this left and right side, we can cancel all the sums and terms. This x square can cancel, y square can cancel. Then here, any other, this 25 and 25 also, 1 and 1 also. So, from the remaining, now here is x, so here minus 10x. If I bring this x this side, it becomes minus 2x equal to, here is minus 10y. If I bring this minus 2y, this becomes plus 2y, okay. Now I'm bringing all the x in one side and all y in another side. So from here, this one we get here minus 12x equal to minus 8y. So minus and minus can cancel. So that means here this will come 12 and 8 also, it is divisible by 4. So if you divide by 4, this will come here 3x equal to here 2y, okay. Next here, number 6. The distance between the 2 points is 2 units. So distance between which 2 points is 2 units. So many points are given here. So distance between which 2 points is 2 units. So you need to find the distance between all these points given. But you can check here roughly without actually finding also. Minus 2, same, that means it becomes 0. So minus 3 plus 4, so we'll not get 2, this one, we'll make it 1. 0 minus 6, so 6 is 36. Then again, that this will not come here 2. 7 minus 6 is 1. 1 square is 1. 2 minus 2, 0, so we don't get. 4 minus 2 is 2. 2 square is 4. So minus 3, 0, so square root of 4 is 2. So answer is this. Here B1, number 1. Here the question asking, find the distance between the following pair of points. Distance. So it is given here 2, 3, here 4, 1. Okay, these are the two points given. We have to find the distance between them. To find the distance between them, let's give here a name. Okay, so let's start here with let A 2, 3. And B for 1 be the 2 given points. Then using distance formula we can say here EB equal to, so as I said here, we will not write the formula but we will be using, okay, that's how to write the formula that one will be using. We say here square root of difference of abscissa. What is the abscissa here? 2 and 4. So the difference of these two, so let's write the bigger one first, 4 minus 2 whole square, okay, then plus 3 and 1, so 3 is bigger, so we write the bigger number here first. So we get here 4 minus 2 is here 2 square plus here also 2 square. So we get here square root of how much here? Here we can say 4 plus 4. So that is here root 8, which is equal to 2 root 2, okay, units. So like this, 2 root 2 units. Then here, like that here, we have to do all these things. So number 2 also, you try, then here number 3, here E, B. It is given here EB, another is here minus A minus B, okay. So like before, we can take here let, this time here I'll say here P, EB and Q minus A minus B be the 2 given points. Then can say here PQ equal to, like before, let's write according to formula. Difference of abscissa E and minus E. Between E and minus E, E is bigger, means positive, E is positive. So let's write the positive bigger one first. E minus minus E. So it will come plus E whole square. And plus here also B and minus B. So if you write the bigger positive first, then minus minus B, it will come here plus like this whole square. So we get here 2A whole square plus 2B whole square. Then here we can say this is here 4A square plus 4B square. Okay. Now from here we can take here 4 common. So if we take here 4 common, 4, then here A square plus B square. Then square root of 4. 4 is a square of 2, so we can say root 4 is equal to 2. So we can say 2 root over A square plus B square. So unit. So like this. So square root of 4 is here 2. So for 2, you have to find the distance between these 2 points. After that, you can find the distance between A and B. Coordinates of A and B is given in the section 7.2. So you can check there, just you have to use distance formula to find the distance. That's it. Now here next question number 3. Determine if the points this and this are collinear. Collinear. Points are said to be collinear if they lie on a single straight line. So these 3 points, okay, suppose if they are collinear means they lie on the same straight line. All these points lie on the straight line. So only when these points lie on this straight line, we can say these points are collinear. Let's say here this point here E 1 5, and here B 2 3, and let's say here C minus 2 minus 11. We can say these 3 points are collinear because these 3 points lie on the same straight line. Now we have to check, we have to determine whether these 3 are collinear or not. For that, so far what we have used is only distance formula. So probably we may use only distance formula. By the end of this lesson, we can use any other way, like area of triangle also. If we use area of triangle, if the area of triangle is 0, we can say they are collinear. But that area of triangle, that will come later. As of now, we have come across only this distance formula. So by using distance formula, let's see here. Now see, look here. Here, these 3 points are here. We can find 3 distance, AB, BC, and AC. So we can say here in this case EB plus BC. This EB plus AC, EB plus BC, this will be equal to AC here. If they are not collinear, then will not be equal. For example, E is here. For example, here E is here. Let's say B is here and C is here. These 3 points are not collinear. So EB plus BC may not be equal to AC because they are not collinear. But if it is straight line like this, then EB plus BC equal to AC. So to check whether these 3 points are collinear or not, we have to find these 3 distance, AB, BC, and AC. And we have to check whether the sum of these 2 is equal to AC or not. If the sum of these 2 equal to this AC, then we can say they are collinear. But here, one thing here, this EBC, we are just taking, we do not know where will be A, where will be B, where will be C. A can be anywhere, A can be here also, okay? So what we have to do is, we have to find these 3 distance. If the sum of any 2 is equal to third, we can say they are collinear, okay? If EBC are precisely like this, means sum of these 2 must be equal to AC. So we have to find these 3 distance. Now let's start here. We can take here first here, let A 1 5, B 2 3, and let's say C minus 2 minus 11, B down 3 given points, okay? 3 given points. Then now let's find out this here, the 3 distance. So EB, let's find out here EB. EB equal to square root of EB, difference of SSR, so 2 minus 1 whole square plus 5 minus 3 whole square. So here we get here, this is here, 1 square is 1 plus 2 square is here 4, so we get here root 5. And let's see here BC equal to BC 2 and minus 2, so bigger one 2 we write, minus 2 it will come plus 2, so whole square plus here 3 is bigger than minus 11, so 3 minus 11 will come plus here like this, so this is equal to 4 square is 16 and plus 14 square is 196. Okay, so here it's equal to, if we add these two together, how will come 212. How is correct? Okay, so square root of 212 now is equal to square root of 212. Let's see here, 212 210 then here 253, so that means 4 root 53. So become little weird, so here 2 plus 2 4 square is 14 square. So we can write this one 2 root 53. Let's try and see. Then here next one here EC. If you write here EC equal to square root of EC. E is this, C is this. So 1 and minus 2, 1 is bigger, so we'll be writing bigger one first, so it will come 1 plus 2 whole square, then plus 5 plus 11 whole square. Then here we get here 3 square is here 9, then plus 16 square. 16 square is how much? 16, 6 is a 36, 9, 6, so 1. So here becomes here 256. So here 256 equal to here root, how much here? 265. So 265, if we find the square root of this, let's say 5 5s are 25, 5 3s are 15. So that means here this one 5 5s are 25, 3 only this, root only this. Okay, we can't simplify this. Now here we can't forget about whether the sum of any two is equal to third. We can't even add here. We can't add this two, we can't add this two. So here the sum of any two is not equal to the third, not equal to the third. Therefore E, B and C are not collinear. This. Next here 4. Check whether this and this are the vertices of an isosceles triangle. We have to check whether these 3 points forms an isosceles triangle or not. We know isosceles triangles means triangles where 2 sides are equal. So we have to find the 3 sides of this triangle and we have to check what type of triangle is this. If 2 sides are equal, then we can say isosceles. So these 3 given points, let's take as, let's say ABC. So let's say here, let E 5 minus 2, B 6 4 and C 7 minus 2 be the given points. Then by using here distance formula, we can find here EB. EB equal to square root of here 5 and 6, so 6 minus 5 whole square, then plus this is 4 plus 2 whole square. So we get here 1 plus 6 square. This square is 36. We get here root 37. Then here BC, let's say BC equal to, BC will be 7 minus 6 whole square plus this will come 4 plus 2 whole square. So here it comes it is same. So here 1 plus 4 for the 6 is a 36, so equal to root 37. Now 2 are equal. Then let's find out this AC also. AC will be here square root of 7 minus 5 whole square plus minus 2 plus 2 whole square. Minus 2 plus 2 is 0. So here we'll get only 2 square. 2 square is 4. Okay, so that means we'll get here 2. Now here we got here 3 sides. Out of these 3, 2 are equal here. Root 37, root 37. That means we can say here EB equal to BC. Okay, therefore the given triangle is an isosceles triangle. Here in question number 6, what type of quadrilateral form? Name the type of quadrilateral form, if any, by the following points and give reason for your answer. So we have to check what type of quadrilateral is this, and we have to give reason. For that here, let's take here the 4 points A, B, C, D. Okay, so by taking these 4 points, what we have to do here, let A, B, C, D be the 4 points. What we have to do is we'll be finding here the 4 sides and 2 diagonals. To determine what type of quadrilateral it forms, we cannot find only the 4 sides. We have to find the 2 diagonals also. For example, say if 4 sides equal and diagonals are not equal, then rhombus. If 4 sides are equal and diagonals are equal, then square. If their opposite sides are equal and diagonals are also equal, then in that case this is here rectangle. If diagonals are not equal, then that will be here parallelogram. For example, say here like this. Here the 2 diagonals are not equal. These opposite sides are equal like this, and diagonals are not equal. In that case, that is a parallelogram. If diagonals are equal and opposite sides are equal, then it is a rectangle. So to check what type of quadrilateral it forms, we need to find the 4 sides and 2 diagonals. Now let's find the 4 sides here for this one, number 1. 4 sides and 2 diagonals here equal to EB. So EB equal to 1 minus 1, so it will become plus here like this. Then here 0 and minus 2, 0 is bigger, so the bigger one we write first, then minus 2, so like this, minus it become here plus. Then this is equal to 2 square plus 2 square. Okay, so in short we can say here 2 times, so I will do here something here, look here, 2 square plus 2 square means we can say 2 times of 2 square. 2 square plus 2 square is, we can say 2 times of 2 square. This one we can write here 2 root 2. This square and root can cancel, so it becomes this 2. This remaining root 2 here. You can get here root 8, then we can write like this also. Same. The next one here, BC. So for BC here, 0, 1 and minus 1. So we can write 1 plus 1 whole square, then plus, then 2 minus 0 whole square. So this is equal to here 4 plus here 4. Same like that only. So we'll get here root 8 equal to 2 root 2. The next one here, CD equal to, now CD. Minus 1 and minus 3. So here will come minus 1 minus 3. Abscissa minus 1. Which one is bigger here? Minus 1 is bigger. So let's write here bigger one first. Minus 1, this will come plus 3 here whole square. And plus 2 minus 0 here whole square. So we get here this also we get here root here 4 plus here 4, so it's equal to 2 root 2. Then here again here ed equal to ed, so this will be bigger one minus 1 here plus 3 here whole square, then plus 0 plus 2 here whole square. So it seems here we get here same all here. That means here root 8, so it's equal to 2 root 2. Now as I said here, we have to find the two diagonals also. Now AC equal to, so this is here will be minus 1 plus 1 whole square plus 2 plus 2 whole square. So here we get here this is 0, 0 plus 2, here this is here 16. 4 square is 16, so we get here 4. Then here BD, so BD and BD equal to BD, so B and D, so 1 plus 3 whole square plus 0 minus 0 whole square. So this is we get here only 4 square, that is 16, so it's equal to here 4. Now here the two diagonals are equal, here 4 4. If, as I said, if two diagonals are equal and the 4 sides equal, then that is square. So this is square. So the question asking to give reason. So the reason is why, okay, it is a square. The reason for being square we have to mention here, okay. That is here, you can say here, we can say here the 4 sides, here the 4 sides are equal and the two diagonals are also equal. Therefore, therefore, you can say it is a square. So the reason, the question asking to give reason, the reason is 4 sides are equal and diagonals are also equal. Because of that, it is a square. Here, 1/2. So let's take here the this one, 4 points is A, B, C, D. Let A minus 3, 5, B 3, 1, C 0, 3, and D minus 1, minus 4, beta 4 points. So like before, we can find here EB equal to square root of, this will come 3 plus 3 whole square plus 5 minus 1 whole square. So we are equal to 6 square plus 4 square. So equal to square root of 36 plus 16. So we get here root 52. Root 52 is equal to 2 root 13. Okay. This is 4 into 13 is this. Okay. Then here BC equal to square root of 3 minus 0 plus 3 minus 1. So equal to 9 plus 2 squared is 4. So we get here root 13. And next here CD. So CD equal to, you can see here 0 is bigger than minus 1. So 0 minus 1. So we come like this, and plus 3 plus 4 whole square. So 0 plus 1 is 1. 1 square is 1. 7 sevens are 49. So we get here root 50. Root 50 is equal to here 5 root 2. Then here ED equal to ED here minus 1 is bigger, so minus 1 plus 3 whole square, then plus here 5 plus 4 here whole square. So this is here equal to here 2 square is here 4 plus 9 square is 81. So we get here root here 85. Root 85 505. So let's see here 85. So 5 1s are 5, 5 7s are 35. So we can write only like this, root 85. And we have to find the diagonals also. So let's find out diagonal. So that the two diagonals are EC equal to square root of, so 0 is bigger, so 0 plus here 3 whole square, then plus here 5 minus 3 whole square, so equal to square root of here 9 plus here 4, so equal to, we get root 13. Then again we have to find this BD, the other diagonal BD, and also so here BD equal to square root of BD, so 3 is bigger, so 3 plus 1 whole square, and plus 1 plus 4 here whole square, so it's equal to 4 square is 16, 5 square is 25, so we get here root 41. Now look here so far we are finding, look like we have a problem here. Look carefully. EB equal to 2 root 13, BC equal to root 13, then here CD is this, then CD equal to 5 root 2, and ED is here root 85, and AC is here root 13, and here BD is here root 41. This is what we got, but it appeared to have one problem here. The problem is here, look, see, if four sides equal, we can say square or rhombus. If opposite sides equal, then it is a parallelogram or rectangle. But this 4 point doesn't satisfy that conditions. That means here we cannot say now it is a square or rectangle or rhombus or something. But here you see the sides here closely. Here 2 root 13, here root 13, here root 13. So this EB, BC, AC, this BC root 13 and AC root 13, if we add these two, then we'll get 2 root 13, which means here BC plus AC equal to EB. According to this, what we get, BC is root 13, root 13, root 13 plus root 13, we get 2 root 13. So that means BC plus EC is equal to EB. That means these 3 points EBC, these 3 points EBC are collinear. Maybe like this here, for example, say here B, then here C, okay, then here say E. Now BC plus EC equal to EB. That means the 3 points are collinear. Because of this, we can say 3 points are collinear. If these 3 points are collinear, with the remaining 4th point, it forms here a triangle only. In this case, it doesn't form quadrilateral. It forms a triangle because 3 points are collinear. So we need to conclude the answer properly. This one here like this. We can say here BC plus EC equal to root 13 plus root 13 is equal to 2 root 13. This is equal to EB. Okay. So you can say here, therefore, E, B, and C are collinear. Since the 3 points are collinear, EBCD is not a quadrilateral. Quadrilateral. Instead, quadrilateral. Instead, it is a triangle. So we have to give the conclusion here properly. So this EBCD, this will be a triangle because EBC 3 points are collinear. Because of that here, as I have explained here, this one, if EBC are collinear with the remaining 4th point, it forms a triangle only, not a quadrilateral. Now let's do here this Roman number 3. 3 here. So like before, we can take let E 4 5 be the given points. Then let's find here EB. 7 minus 4, 6 minus 5, so we get here 3 square plus 1 square, that is here 9 plus 1, so we get only here root 10. Then here BC equal to, we see here 7 minus 4 whole square, and here plus 6 minus 3 whole square, so we get here 3 square, here 9 plus here also 3 square, we get here 9, so that means here root 18, so it's equal to, we can say here 3 root 2. Then here CD equal to, CD we can say 4 minus 1 whole square plus 3 minus 2 whole square, so we get here 3 square plus 1 square, so that means here we get here 10. Then CD ED equal to 4 minus 1 whole square plus 5 minus 2 whole square, so we get here this one 3 square plus 3 square, so that means we get here 2 times of 3 square, so equal to 3 root 2. Same thing, how we get here 3 root 2, 3 square plus 3 square will get 3 root 2. Same thing here also. Then let's find out these diagonals. EC equal to, so EC 4 minus 4, so here 0 plus 2 square is 4, so that means we get here 2. Then here BD is equal to, here 7 minus 1 whole square plus 6 minus 2 whole square is equal to, here this is here 6 square plus 4 square, so we get here 6 square is 36 plus here 16, so we get here root 52. Okay, so this 52 is equal to so we can say here 2 root 13. Okay, 2 root 13. Now here it seems to have one problem here. Now here AB is here root 10, 3 root 2 root 10, 3 root 2. Opposite sides are equal and diagonals are not equal here. That means this is a, see EB here, what we find is here like this, E, B, C, D. EB we get here root 10, BC is here 3 root 2, and here also CD is root 10, and here 3 root 2, okay, to do diagonals here. So opposite sides are equal and diagonals are not equal. If diagonals are equal, this will be rectangle, but this is not a rectangle because diagonals are not equal, so this will be parallelogram. Okay, so you have to tell that. Here opposite sides are equal and diagonals are not equal. Therefore it is a zero. Next here, number 7. Find a point on the x-axis which is equidistant from this and this. So find the point on x-axis. So let's say this is x-axis. Find a point on x-axis which is equidistant from these two. So let's say one point is here, 2, minus 5. Another point, let's say here, minus 2, 9. Let's say this one here A, here B. We have to find a point on this x-axis which is equidistant from these 2 points. So let's say here a point here, just take P, okay? P is equidistant from E and B, which means EP is equal to BP. Equidistance means same distance. So P is equidistant from E and B. So that means AP is equal to PB. So this point we have to find. We have to find means we have to find the coordinate. We don't know the coordinate of this, but here one thing we know, this is x-axis. If it is x-axis, for every point on x-axis, ordinate is always 0. So we can take this one 0. And this abscissa we don't know, so unknown one we take here x. So we have to find here this P. So first let's take here let P x0 be the point on x-axis which is equidistant from E 2 minus 5 and B minus 2 minus 9. Then according to question here, P is equidistant from E and B. That means here EP is equal to BP. So like before here, we have to use the square root here when you use the distance formula. But if we put here square, if we square on both sides, then we can write without that root like before. So we can write like this. So AP square, AP. So by using distance formula here, x and 2, so we can write here x minus 2 whole square. Then here plus 0 and minus 5. 0 is bigger, so here 0 minus 5, so it will come plus 5 here whole square equal to BP. So x plus 2 whole square plus here 9 minus 0 whole square. Then here this one we can write here a square minus 2ab, so it will come here 4x plus b square, so that is here 4. Then plus here 5 square is here 25 equal to a square plus 2ab. 2ab will come 4x, okay, and here plus 4, then plus 9 9s are 81. Then after that here the same one we can cancel, so that means this x and this x we can cancel here. Then this even 4 and 4, this is minus 4x, this 4x. If you bring this side, it will come here minus 4x equal to yeah, 81 minus this 25, bringing this side, so minus 25. So we get here minus 8x equal to, if you subtract this one, so here 6, then here 5, okay, so we get here 56. So that means 56, 8 is a 7 is a 56. So here we can write directly minus 7 also. So here minus 56 by 8, so we can say here minus 7. So it is a 56. So x value is here this one. So now you can say here, therefore, for conclusion, therefore you can say here minus 7 0 is the point on x-axis. Just in short. Number 8. Find the value of y for which the distance between the points P and Q is 10 units. Just like 7. But the distance between PQ is 10. So here nothing much to write. We can just start away. So here, this is question number 8. Say as per question. You can say as per question. Here, according to the question, here PQ is equal to 10 units. This is what it says here. So to use distance formula, let me square on both sides. PQ square equal to here 10 square. So PQ here, putting the value of this PQ, P is 2, here opposites are 2, and here Q here 10, difference of these two. So we can write here 10 minus 2 whole square, then plus this is minus 3 and y is bigger, so y plus 3 whole square equal to, you can say here 100. Now from here, this is 8 square is 64, and plus a square plus 2ab, so this will come here 6y plus 9 equal to here 100. Then here y square plus here 6y, okay. 64 plus 9 is here 73, then here minus 100 equal to here 0. We get a quadratic equation, so we have to solve this. So this will come here minus how much here 27. This 7 equal to 0. We have to split the middle term. So this will be 3 9s are 27. So that means this will be 9 square, then plus 9y minus 3y minus 27. So we split like this middle term 6y we split into 2, and from here we can take here 9 this y common, so y plus 9 remaining. From here minus 3 taking, so this minus is taken here, so plus 9 remaining equal to 0. So from here we can take common, so here comes like this equal to 0. So from here we can say here either y plus 9 equal to 0 or y minus 3 equal to 0. So from here we get y equal to minus 9 or here y equal to 3. So the question is asking to find the value of y only. So y is 9 or 3. That's it. So nothing much to conclude. You can stop here. Then next one here, number 9. So according to this line, you see Q is equidistant from P and R. Find the value of X. Also find the distance of QR and PR. First we have to find the value of X. For that, here is given Q is equidistant from P and R. For example, say here Q is equidistant from P and R. So let's say here P, and let's say here R. So Q is equidistant from this P and R, which means this PQ is equal to this QR. So according to the question, these two are equal. Okay. Now according to the question, this is given as here 0 1, and P is here given as 5 minus 3, and R is given here x 6. Okay, x 6 like this. Now this is question number 9. So just we can start here as per question. Here this QP equal to QR. If we square on both sides, then QP square equal to QR square. If there is square, we can use here without root. So on this one we can write here 5 minus 0 whole square plus 1 plus 3 whole square equal to QR. So we can say x minus 0 whole square plus 6 minus 1 here whole square. Now from here this is equal to 25. 4 4s are 16 equal to, this is x square plus 5 5s are 25. These two can cancel. So we get here x equal to, we can say plus minus root here 16. So this is plus minus here 4. So here x value can be plus 4 or minus 4. So since we are getting two values of x, okay, we have to find this QR twice and PR also. So let's find out, let's check. Yeah. Then let's find out then when when this x equal to, let's take here 4, okay? When x is 4, this QR equal to, see QR, so that means here, this x is 4, so 4 minus 0 whole square. Can you see here? X is 4, 4 minus 0 whole square plus 6 minus 1 whole square. So this is equal to 16 plus 25. So here, this one here, one root will be there. So equal to a root, this is, we get here only 41. So we'll stop here only. So this one here, unit. Then here, this one, another is QRN PR. So PR equal to, okay, this is what we get. So here, unit. Here again, when x is here, minus 4. First we find here when x is 4, we get QR and PR like this. Now when x is minus 4, we get QR equal to root 41, which is same with the previous one, and PR equal to root 9 root 2 unit.